So we are going to be working through this with graphing calculators today and into tomorrow. There's not an assignment with graphing calculators that I would expect you to do outside of class because the graphing calculators have to stay in class. So any practice with the graphing calculators will actually happen in class. There are some questions on the test that I do have you use graphing calculators for. This is not the only time we use them in this chapter. So as we go through this, do not just tune it out and say, oh, this isn't going to be on the test. I'm not going to have to know how to type everything in. You may have to. So they are used on the test, and anything we do today could be on there, knowing how to type data in. So make sure you're following along. Make sure you ask questions if you're not getting the right screen. The reason this lesson is 2 days, I take it slow, expecting I'm going to be walking around and helping people figure out their calculators. You may not have used these before or used them to do what we're doing today. Aside from actually using the calculators, though, you have to understand what we are finding. So the only reason we're using the calculators is it makes it more efficient to find the information that we need. So on Friday, within the lesson, you were finding or reviewing how to find mean, median, mode, variance, standard deviation, the 5-number summary. All of that can be found on your calculator, not by punching in a bunch of numbers just to calculate it with your calculator, but you can just type in your data set and your calculator can find all of that information for you. So that's one thing we're going to look at, is how to have the calculator find it for you. And then also, we're tying this into the distributions of data. So whether your distribution is symmetric or negatively or positively skewed, that determines what measures of center and spread you should use to actually describe your data. So this first part is understanding when you see a distribution, what type of distribution is it, and then should I be using the mean for the center or the median for the center, the standard deviation for the spread, the range for the spread, what should I be using? So at the top, we have the definition of what a distribution is. It shows the observed or theoretical frequency of each possible data value, how often it could occur. The shape of a distribution can be seen by drawing a curve over a histogram. So we're looking at histograms first, which are like bar graphs. We are also going to be looking at box and whisker plots for the second example. So what I want you to notice from here is, well, actually, I'm going to start by describing the symmetric distribution. So when your distribution is symmetric, first of all, just visually look at what that looks like. What this means, though, is that the mean and the median are approximately equal. So there's two different measures, or I guess 2 different common measures of center that was referenced on Friday's lesson: the mean, the average of the data set, and then the median. So if the distribution is symmetric, those 2 numbers are approximately equal. Notice they don't have to be exactly equal, but they approximately are equal. And then the data are evenly distributed on both sides of the mean, or approximately evenly distributed. Okay, so that would be a symmetric distribution. And then usually this happens if there's outliers, but it could happen even without an outlier. You get a negatively skewed or a positively skewed distribution. So you would need to know not only would it be skewed, but is it negatively or positively skewed? So look at kind of what those visually look like. Negatively skewed, and they describe it as having a tail. You can kind of see where the mean and the median would fall. When it's negatively skewed, that means there's values that are lower that are pulling that data set down, and that pulls the mean down as well. So the mean then ends up being less than the median. And what happens here is the median ends up being a more accurate representation of the center because the mean is being affected, it's being pulled down. The majority of the data, though, are on the right of the mean. So the majority of the data are still on this side. You just have this tail of values that are on the left side. and that would be a negatively skewed distribution. So then it's opposite if it's positively skewed. Positively skewed, the tail is on the right end. The mean is actually higher than the median. So the mean is greater because those values that are on the more positive end are pulling the mean up. The median is less affected, but the majority of the data are on the left of the mean. So the majority of the data are where those taller bars appear. And the tail is then on the right side. And then what it says below, before we actually get into an example, when a distribution is symmetric, the mean and the standard deviation accurately reflect the center and spread of the data. So this is learning then based on the distribution, what should we use to actually describe, now that we have all of these different calculations or ways to describe center and spread, which one should be used. So if it's symmetric, we should be using the mean and the standard deviation. However, if the distribution is skewed, those measures or those statistics aren't as reliable because outliers have that strong effect on the mean. Like I said, the mean is being pulled in whatever direction that tail is in, and the median is less affected by this. So when the distribution is skewed, the mean lies away from the majority of the data toward the tail. The median is less affected, so it stays near the majority of the data. So you first need to determine the distribution, skewed or symmetric, and then this down here is really what you need to focus on. If the distribution is symmetric, you will be using the mean and the standard deviation to describe center and spread. If the distribution is skewed or has outliers, you will use the 5-number summary to describe the center and spread of the data set. So you would find the min, the max, and then the 3 quartiles, because that would be the median then for your center. And if you know the min and the max, you could find the range for the spread. So now we're actually going to put this to use. This is what you need to remember, and now this is how to get that information using the graphing calculators. You just have to know what information you're trying to find. We have here, for example, 1. Alyssa recorded the amount of time in minutes that she spent waiting in lines for rides at an amusement park. So these are her different times. So part A, I have some directions as to how to type things into the graphing calculator here. I'm also going to be showing it as I type it in. And anything you need me to repeat or show again, please say something so that you're able to type this in along with me. But it says use a graphing calculator to create a histogram and then describe the shape of the distribution. So is it symmetric or negatively or positively skewed? So like I said, directions are here, but you can also watch what I'm doing. So you first have to press the stat key, which is right here. So it's in the 3rd column of keys, 2nd one down. So you press stat, and then you actually want the very first option that's already highlighted. You want the edit menu, so just hit enter, or you can hit the number 1. And then whatever comes up on yours, you might have things typed in. You might have different list names along the top. That's all okay at this point. Does anybody, I guess I should ask this, does anybody have numbers actually typed in their lists? A few of you. Okay. If you do, here's how to clear it. What you want to do for each list, use the arrows here. So you would arrow up to highlight the name of the list, and then hit the clear button, which is the top key in the very last column. It's under like that down arrow. Hit clear, and then hit enter, and you should see everything in the list is cleared out. Okay, and then if you have multiple lists that are filled in, just arrow over and up again to highlight the name of the list, hit clear, enter, and do that for every list that has numbers or values in it. Anybody having trouble clearing their lists? Awesome. Okay, does anybody have different list names, not L1, L2, L3? Okay, so That'll just help later. It really shouldn't, I mean, your calculator is probably already programmed that your list names are where they should be to actually create what we need, but we'll double check that. So just to double check, everybody right now would be typing in L1. Everybody has an L1. Okay, so now here's what you do. You are literally just typing all of these numbers into this list. So you type one number and then you hit enter, type the next number and continue. So I would just type in 64, hit enter. You can see then it's added to your list. And just don't rush through this because you don't want to miss a number. You could cross them out as you enter them too if you are afraid you're going to miss something. And you should have, there's 26 values in this table. So when you're done, if you just want to double check, at the bottom, it should say L1 with a 27, because that means it's ready to enter in the 27th one, but there isn't. So if yours doesn't say 27, that means you don't have all 26 entered in. Okay, are we all good? I don't want to move ahead of anybody. All right, so then from here, once you have these entered in a list, now we're going to go and we're going to set up the calculator to actually make a histogram that we would not have to draw out by hand. So from here, what I want you to notice along the top, you have 5 keys. And the very first one says y equals on it, but above that, mine's in blue, so if you have a yellow cover, it's in blue. It might be in that yellowish orange if you have a black covered calculator, but it should say stat plot. That's what you want to get to. So you have to hit the second key, which is the top key of that first column, hit second, and then stat plot. You should get a screen that looks like this. And we're going to be working with plot 1, so as 1 is highlighted, just hit enter or hit the number 1. And we want to turn this on. Maybe yours is already turned on depending on who used your calculator last and what they were doing. So right now my off is highlighted. I want it to be turned on. So as the cursor hovers over on, I want to hit enter so the on is highlighted. So make sure on is highlighted. And then if you arrow down, you should see there's different types of graphs your calculators can make. The first one would be more of just plotting points as dots, like a scatter plot. The second one would be more like a line graph. The third one is actually the one we want. That's the histogram. Looks like a bar graph. So you would arrow over to that option. So the cursor's over it, hit enter. So that one is highlighted. And then I'm going to arrow down. Here's where you need to make sure X list. So if all of you entered your list into L1, it should say L1 here. Does anybody say anything different than L1? Okay, because that's saying what numbers are your, or what list are your numbers in. So if it says something different, this won't work. Frequency, you shouldn't need to do anything with that. I've never changed that. I'm honestly not sure what it does. So from here, before we actually graph this then, once that screen's all set up, I want you to hit your y equals key. Don't hit second first, just hit y equals. Oh, never mind, maybe I need to do this first. I'm going to go back to the home screen actually, so I'm going to hit the second key, and the key right next to it, mode, above that it says quit. So anytime you want to get back to your home screen, you can hit second mode for quit just to get back to home. It saves all the information I just put in there is saved. Some of you, maybe your y equals did work, but I want to be on this screen. If I just hit y equals, this is the screen I want to be in, it wouldn't let me go there before. Anybody not able to get here? That was kind of confusing. Anybody else not able to get to the y equals? Yours might look different. I'm going to point out some things you should look for. While you're on this screen, what I want you to make sure of is along the top, only plot 1 should be highlighted. If you have either of the other two highlighted, you need to arrow up and over them. And hit enter to turn them off, or if your plot 1 is not highlighted, that means in the previous step you didn't turn it on, you need to highlight over plot 1 so that you press enter and it is highlighted. So make sure plot 1 is highlighted and not the other two, and then make sure all of these y equals are blank. So if you have something typed in here, just hit clear and it'll get rid of whatever's typed in, but you want all of these blank. This would be how you graph a line or a curve on a calculator. We don't want that messing with our histogram though. So everybody's screen looks just like this. Okay, then to actually graph this, I know there is a graph key. We're not going to hit that because you want to have the right viewing window or viewing screen. So instead, along the top 5 keys, I want you to hit the middle one that says zoom. Hit zoom, and then you're going to have to arrow down. It is zoom stat. So you want option 9, which is zoom stat. So you can either arrow down to number 9 and hit enter, or just hit the number 9, and you should see your histogram along your screen. So now if your histogram looks different, that could mean when you typed your numbers in, something got typed in incorrectly. So right now, anybody not have a histogram or not have a histogram that looks like this? Okay. So I know that's a lot of steps to get this, and especially the first time with the graphing calculators. That's why it takes practice to know what buttons to press to enter things in. Now that we have this though, so this is just saving us time so we don't have to create this histogram by hand. Now we have to look at this and say what type of distribution does it have? So what type of distribution would you say this has? Positively skewed. So I'm just going to make a note on my sheet here. This is a positively skewed distribution. And then there's going to be one other thing we'll have to get from the graphing calculators to answer part B. So part B says describe the center and spread of the data using either the mean and standard deviation or the 5-number summary. So mean and standard deviation go together. The mean would be for the center, standard deviation would be for the spread. The 5-number summary includes both your measure of center and spread. So it's either both mean and standard deviation or 5-number summary. And then it does say justify your choice. So this is what you have to remember from what's up above. If your distribution is skewed, you will always use the 5-number summary to describe it. So I'm just going to make a note because it does say to justify. I'm just going to write here Since the distribution is skewed, the 5-number summary should be used. Okay, so that's the justification for why we're using the 5-number summary. The data is skewed. But then we actually have to find it, and we're going to have our calculator do that. Now, this is what I want you to think about, those of you that were here on Friday. So think about this. There's 26 values in this data table. If we were finding the 5-number summary by hand, we would have to write out those 26 numbers in order, find the median, and then find the median of the lower half, the upper half. It's just a little bit time consuming, especially the more values you have. You do need to know how to do it without a calculator though. So now with the calculator can find those statistics for us. So it does say a little bit here how to get it. I'm going to show you on my calculator as well. You can just stay right on this screen. You should be able to hit, go back to the stat key. So the very first key we went to, stat, hit stat again. But along the very top, notice you have edit, and then you have calc, and you have tests. We want to be under calc. So you have to use your right arrow to go over to calc. And then we want option 1 variable stats. So you would hit enter. This is where if you have an 83, I might need to come over by one of you to see how to type this in. It might be different. So 83s, you do not get this screen, right? If you look at the very top, I should say black covers. If you have a black covered calculator, you do not get this screen. If you have a yellow covered calculator, you do. So if you have a yellow covered calculator, here's what you need to do. Make sure your list says L1. Frequency lists, you don't need to type anything there, so just arrow down to calculate, and then you should get this screen. Okay, now I'm gonna, Jacqueline, I might just look at yours. Okay, black covers, just hit enter. So once you have one variable stats, just hit enter. Anybody not have this?
I don't know. I missed something.
Yeah, I know. I couldn't find it, so then I was like, oh, it's not.
Okay, here's what you're looking at on this screen. And this is where I'm saying not only with the graphing calculators knowing how to type things in, you would need to know if I put, say, this screen on a test and I ask you to identify the standard deviation of the data, you would need to be able to look at this and point out which number I'm asking you to find. So this is where I talked about some of that notation in the lesson on Friday. The notation is important because your calculator will use that notation. So anybody remember what this X bar means? It is the mean. Do you remember if it's the mean of a sample or a population? Okay, so X bar is the mean of a sample. Okay, that should have been on your notes on Friday. I know some of you were gone, but that should have been on your notes from Friday. So we are not finding the mean here. We want the 5-number summary. I'm just pointing out what's on here. This is the mean if we had a sample. This you would not need to ever point out. This is finding the sum. This sigma here is finding the sum of all your values. It's saying the sum is 721. That's what that would mean. This is finding the sum if you squared all of the values. So these two we aren't using. Then we have S, and we have, so S, X, and then we have we have this symbol here. Actually, this is sigma. This is something different up here. S and then sigma, what did those represent from Friday? So if you just have the letter S or you have this sigma here, what did those represent? Those were standard deviation. S was if you have a sample. Sigma was if you had a population. So X bar is used, maybe I should write this on the board here. So X bar is the mean of a sample. Even though your calculator doesn't do this, the mean of a sample and the mean of a population are really the same number. You don't find them a different way. You do find the standard deviations a different way, which is why they're different numbers. But in general, so X bar is going to represent the mean for any data set. But if you had a population, if you see this symbol, this is mu. This would be the mean of a population. So this will not show up on the graphing calculator, but if you see that written somewhere, which you will, this is the mean of a population. That's the symbol that's usually used. So S is standard deviation for a sample. Sigma is for a population. N is how many values you have in your list, which we have 26. So then if you arrow down, and you might need to arrow down, I'll arrow down all the way to the end. The very last 5 values are your 5-number summary. So it gives you the minimum value, it gives you the first quartile, it gives you the median, which is your second quartile, it gives you the third quartile, and it gives you the maximum. These are the numbers we want to write down here. Or if you don't have room, there is room. I did not copy this Friday, so it's not back to back. So there is room if you needed to write on the back of it. I'm going to move the calculator to write this down. So the minimum is 1. Quartile 1 is 12. The median, or if you put quartile 2, that would be fine, is 20.5. Quartile 3 is 35, and the max is 89. Okay, so like I said, I know this is taking a long time just to get you, or to know how to find this on your calculator, but ultimately the point of what you need to understand from this is figure out what type of distribution you have, and based on the distribution, what numbers should be used for the center and the spread, and then be able to identify those numbers. So here, if we wanted to describe the middle of the data, we would use the median as 20.5. If we wanted to identify the spread or describe the spread, we would say the min is 1, the max is 89, there's a range of 88. We could describe the quartiles like we were talking about Friday. That's what this would be used for. Okay, any questions right now? I know that was a lot of information just to answer these 2 things. Okay, so then you might be able to get through this just because now we've gone through how to type everything and you know where the keys are, so there's less, I think, setup we have to do. My goal is to at least get through this next example. This is with a box and whisker plot. So rather than making a histogram, your calculators can graph box and whisker plots. These can also be used to identify the shape of a distribution. Have you made box and whisker plots before? Okay, so at least looking at this, it doesn't look totally unfamiliar to you. So in looking at this, maybe I'll just label it on one of these. The very end, the box and whisker plot really shows the 5-number summary in a sense. This end here would be the minimum. The other end is the maximum value. That line that runs down somewhere inside of that rectangular box that you see, that is the median. And then the 2 outer sides of the box, so what creates the box, those are your quartile 1 and your quartile 3. Okay, so it really shows the 5-number summary. It shows where the min is, where the max is, and then where the 3 quartiles are, including your median. And that's why it's showing for all of these from where your median is to either end. That's marking 50% of your data, since the median is in the middle. So if your distribution, I'm actually going to start with symmetric. If your distribution is symmetric, that means the data are equally distributed to the left and the right of the median. If it's negatively skewed, you're going to see that tail on the left side, just like with the histogram and drawing the curve over it. The data to the left of the median are distributed over a wider range than the data to the right, which is why this seems more spread out here or longer. Data have a tail to the left, and then positively skewed would be the opposite. The data to the right of the median are distributed over a wider range than the data to the left, and then there's a tail on that right side where it's distributed more widely. So this is the same type of question. Example 2 is still having us determine the shape of the distribution, but we're using a box and whisker plot to do so, and then describing the center and spread with the appropriate statistics. So we have the students in Mr. Bege's, I don't know how to pronounce that, language arts class found the average number of minutes that they each spent on homework each night. And that's in the table here. So we are going to use the graphing calculator to create a box and whisker plot and describe the shape of the distribution. So here's what you need to do. If you wanted to on this home screen, you could press clear. That'll go away. You don't have to do that. I need everybody, we're repeating all of the steps we just did. So go to Stat. We can at the very least see what this graph looks like. Go to Stat. Again, we want Edit option 1, so just hit Enter. So it brings you back to that list page. Now you all have something entered in list 1, and we want to clear that so we can enter in a new list. So I want you to arrow up to highlight L1, hit clear, and then hit enter. So arrow up to highlight L1, hit clear, enter, so that's gone, and then start typing in the data that we have for this problem. And there are 24 values, so when you're done typing them in, you should see a 25 at the bottom to show you that you already have 24 entered in. I would just arrow up maybe to the top of the list and then just go through your numbers and see which one you're missing.
Oh.
But you're going to have to make sure you add the number at the very end, otherwise it's going to take out one that you already have in there. All right, is everybody okay typing these in? Okay, I at least want us to see the box and whisker plot, and then we'll continue with this one tomorrow. So from here, we already know our plot 1 is turned on, but we have to change it to a box and whisker plot. So from here, I need you to press second y equals for that stat plot screen. So second y equals to get this stat plot screen. And again, just hit enter so you're on plot 1. Plot 1 is already turned on. Under the type, though, notice there's actually 2 options for box and whisker plots. You're going to actually, once you highlight here, you'll have to use the right arrow to get down to these options. The first one, the difference between these two, the first one will point out if there's outliers, and they'll put them as dots on either end. The second one will just keep your min and max as is. So why don't you highlight the first of the 2 box and whisker plots? That way if there's outliers, we'll see. Your X list should still say L1. Frequency, you don't need to worry about. The mark is just how the points would appear. So if you wanted to change it to something else, you could, but you can leave that. Anybody not have this screen? Did you get the box and whisker plot highlighted, Grace? Okay, this will be quick. From here then, you should just be able to hit zoom. Of the top 5 keys, the middle one, hit zoom. And then, again, you can arrow down to zoom stat or just hit 9. And you should see a box and whisker plot appear on your screen. So zoom 9. And I realize we're close to the end here, but in looking at this, what would you say the distribution is? I would say this is pretty close to symmetric, yes. Symmetric doesn't have to be that they're exactly the same length on either side, but if they appear to be the same, you can say it's symmetric. Okay, so we will continue with this example and the rest tomorrow. Here's what I need you to do, though. I need you to make sure before you put the covers back on your calculators that they are turned off.